Then we start again, and I would like to, for the second time, to welcome James Nobis back to Bergen, Norway. He was also here in December, presenting on rainbow tables. And this then is not the same presentation over again. This is most definitely new content, and I should say, at least to me, it's very interesting very interesting topic that I will be presenting on. So, James, you want to guess?
So we'll run down a quick bio on me. Background information, if you're not familiar with rainbow tables, it's going to be very brief though, and then we're going to talk partially about our new file format, which enables less disk space use and is actually an enabling factor for the two things that I'm actually really here to talk about. So freerainbowtables.com basically is a project in which our budget is generally, oh, you'll give us free hosting? That's fantastic, okay. So our budget is free to very cheap. So no, we don't make money. And we get a little bit of ad revenue. Anyway, so this has nothing to do with my day job. That's my official day job title. Mostly I do Linux OpenBSD administration. I do some programming. NetBSD happens to be one of the servers for the project that I run. I have a university degree in computer science, and I don't even work in the security industry. This is all a hobby for me. Okay, this is the entire amount of background information you're going to get on rainbow tables if you are not familiar with them. If you're not familiar with them, you'll just have to watch my talk from Passwords 10, and I'll make the slides available and the PDFs, all of the reference links, like the one at the bottom. You can simply click and it'll take you to the citation with the URL and so forth. In addition, I did bring some DVDs that have all of the Passwords 10 talks that are sitting on the desk for those that either haven't downloaded them or are going back to places like where I live where download speed is slow. Feel free to grab one of those or see the reference to download them. All right, so rainbow tables refers to a generic time memory trade-off for essentially any cipher, any hash, and when specifically talking about ones of cryptographic nature for the most part. We're not talking about CRC or other strange things that people sometimes ask us if we can make rainbow tables for, which never quite made sense. So the other part of it is that it is probabilistic in nature. While the tables we generate are 99.9% probability of finding your password, they are not lookup tables. As an example, here is a key space. I believe this one is the one for lower alpha. Never mind, I put it up there. That's from an MD5 set we did. This lower alpha length 1 through 10. That's the key space 2 to 47, so on. If you actually did that, it's just a basic lookup table with nothing special whatsoever of storing. Well, actually, that would only be the storage of the MD5. Anyway, so actually the storage is larger than that, but it makes the point nonetheless. In our original format, RTI, it's about 280 gigabytes, and that's base 2, not base 10 hard drive manufacturer math. In our new format, that same set is approximately 112. And that's the success rate for that table. It's somewhere approximately greater than 99.905, which depends on how many extra chains we end up generating and other things. All right, so RTI2 is the file format that we've had for years is just RTI, and the original rainbow table format, which is called RT, the file extension .rt. RTI just is rainbow table improved, essentially. The initial design and implementation, and I wish that I had people that are no longer in the project. His online name is Powerblade, or I refer to him as Martin generally, was one of the people that originally wrote it. And then well, actually, sorry, he originally did part of RTI, and then he pretty much independently worked on what was the first draft kind of RTI 2. And then we decided that it would be best if we had some sort of header, because right now the very long file names essentially encode all the data about that given file, which starts to get a little bit absurd. The header design is from someone in the forums, Scoots, who more recently has started to actually use his real name in a lot of things, C. Thomas. And he essentially makes a lot of things possible, whether it's fixing my inability to add, which happens a lot in the, when we're computing things, and for programming and so forth. And essentially, the citation there is a link to our forums, which is basically the specification for the actual format that we ended up going with. Essentially, before, for anyone familiar with the tables, we had, for each data part, we had a .rti file and a .rti.index file. Formats changed so that the data and the indexes are in a single file. And we're storing all the parameters in the header of the file, and so at some point in the future, we won't get posts like I just saw 2 days ago, in which someone had renamed the file to something like my rainbow table.rti and wanted to know why it ceased working. In the previous format, it's a fixed length for the chain store, which obviously when they're 0 bytes, it's kind of silly. So this format is variable length chains, which means we can make more efficient use of the data. They are bit packed in a sense, except we are not fully bit packing. It's sealed to the next byte. And Project Rainbow Crack, when they did RTC, that's actually the approach they took for their, and they refer to it as bit packing as well. Other important part is RTI2 allows per position character sets, which in particular we always are getting requests for, can you add an exclamation point there, a question mark there, and in the current format, that's actually a bit difficult. So this should enable more flexibility. And this is just a quick performance comparison. These are actually hashes that I had run in December. And that's a comparison between the RTI and the RTI2 set. In particular, you'll notice the biggest change being on the disk access time, which for that particular set, disk access time is starting to become quite a bit of the bounding factor. All right, hybrids. Why do we need them? Why is it taking us so long? And what's hybrid 2? So we've generated a few key spaces of rainbow tables. This is a sampling. Pretty much almost all of these sets exist for both MD5 and NT LM. I've got some notable exceptions up there, which is, if you take a look at the fourth one down, LM-FRT, that's actually a landman set that includes a very good chunk of almost every possible character. Landman, actually you break in halves, so you don't ever have to break more than 7 characters at a time. And other than that, so we've kind of run through a lot of the things as far as key space, size, attack time is just for, purely just doing a key space without any sort of intelligence. So it's time that we move on a bit. Those last sets, key spaces anywhere from 2 to the 36 to 2 to the 47 and some change. And the sizes on disk for all those sets range from anywhere from 1.8 gig to 530 gig. We already have some new sets that are essentially complete but not yet released with a bit larger key space. And if you note the sizes, basically it's completely impractical to release those as RTI, even for us on the generation side where we don't have an infinite supply of disks. And the other part is when we've got full generation going between the Blink clients for those key spaces that are on the high end, it's 61 days for the client generation side of it to do the full set. So not that long. I think we have about 1,000 users attached and some number of GPUs and CPUs. So options we have instead of looking at hybrid key spaces could be, should we go for a lower success rate? This is what Project Rainbow Crack, which is, I should mention that a single one of their large tables runs for about $1,200 US. And most of our sets, we cover pretty much almost all the sets they do, and we don't, we give them away. Because not everybody can convince their IT staff to spend $1,200 times some number of tables just to do some basic security auditing. And for that matter, some of us actually can use them in our day job as both Martin and I are system administrators during the day. Another option, a lot of people are always saying we should just ignore everything except for graphics cards. And personally, I own one and only one graphics card that's capable of doing compute things, NVIDIA CUDA card. And I purchased that in October simply for this project. And I don't think everybody has a graphics card, and especially on laptops, graphics cards are generally so quite limited. So why should we settle for less? I don't think we should. Some people think so, but nah. So our first attempt for hybrids was actually quite old, and this was something that it's kind of fun to read. Okay, it's fun for me to read, in which Scoops was discovered the fact that there was a bias in the key space that he didn't quite, at first he wasn't quite sure what exactly the bias was, and then it turned out that it made some, ended up making some passwords twice as more likely to be found, so the actual success rate of the tables was much lower than expected. For that set of that type of hybrids, first character set, fixed length, and then you could only have 2 character sets where you had, like your 7 lower alpha at the beginning and your variable length numeric 1 through 3 at the end. And that's all you could have. You couldn't have more than that. All right, so moving along, hybrid 2. Again, Scoops basically said, hey, well, we can fix it and just treat each character set as a key space of itself, or a sub-key space, and you put them together and you have the full key space. The code is finally complete and deployed, at least on the CPU side. Yes, I was fixing bugs like a week ago in the generation code, so it's not quite, but. And this is the set that Per was talking about, and he can call them boring password statistics all that he wants, but they're extremely useful password statistics as they form some of the basis for the decision to make that set. So we already have a set that covers mixed alphanumeric length 1 through 8, so this is a set to complement that. And yes, that is length 9, 10, or 11, with the given characteristic. The first character is uppercase, 5 lowercase, and then 2 alphanumeric, and then you have anywhere between 1 and 3 numbers on the end. And we need good statistics. And Per seems to have some data, and when he has time, as he always mentions, that he needs to have time, as we all do. He plans on putting together more posts and so forth. And so anyone else with good corporate data and password statistics, like you can share or hint at sets that you would find useful if you can't share. That's very helpful because I do not work in the security industry and I'm at a small company, and so my access to real corporate password statistics is extremely limited. So the project is very community driven. Give us feedback on what there's need for, what we should do, where we should go. Okay, so the full implementation allows multiple character sets per sub-key space, but we're going to just take a look at the one that's the simplest first, which is the one that we're doing. And simply, you take the key space of each sub-key space, and you end up with the total key space. So you effectively, go through the reduction function, you take it for the first key space, you then go and do the next one, you concatenate those, and you continue on. The only limitation really to hybrid 2 is that the only character set really to have in this first implementation, now this is the implementation that will change, this isn't a limitation of the file format. Right now only the final character set can have the variable length. All right, so sub-key spaces. Per position character sets, 4 different lengths, and multiple character sets for any given position. Can allow some things like ordering the table for faster attacks. In fact, that's something that Project Rainbow Crack has already done, and it does get very interesting. All right, Omni 6 will be an interesting topic, and let's see, I'm not doing too badly. This is a paraphrase from Scoots yet again, and essentially the reduction function, as you're going along, it happens to be a divide and mod. If the key spaces were not increasing, then you would have some issues mapping that. So, this is what Scoots refers to as Omni 6. He actually has a full character set, or rather full key space of something that's called Omni 5 that's on his site for his hash lookups on Omni 5. I think, I forget if it's an average of 200 milliseconds or if that's the max bound, or it's either that the max bound is 200 milliseconds or that the max bound is 1 second to do the lookup. And that's a website with, I believe, PHP in the front end. The reason for the name Omni is the asterisk there, Omni meaning all, and Omni 6 specifically referring to the second line down, in which there are 6 of them. And that actually refers to 95 characters, not all per se, but that's what a lot of people refer to as all, because you're talking about the space well into, covering alphanumeric, upper, lower, and 32 symbols. And that's same thing with John the Ripper or any other tools. Generally, that's considered all. So what you see, the whole thing down the left side is actually an ordering of sub-key spaces that he defined for what he called Omni 6. And now that actual construct as is, we can't directly turn into rainbow tables, so it does have to be reorganized to a degree. And this is actually that reordering. I'm showing his format down the left side, and then down the center is the key space for each of those sub-key spaces, and on the right-hand column is actually the size on the actual size if we generate it as RTI2 using a chain length of only 20,000, which means they'll be quite fast. For about the last year, most of our tables were generated with a key space, with chain length of 40,000, and in these larger sets we've moved to 60,000. That doesn't actually increase generation time, it decreases disk space usage, it does increase attack time. The reason for the 0 there is that got transformed into numeric of, I believe, length 10 to 11. But so the total size of that is actually quite small. And what happens here is, given this full set, instead of just having an aggregate where you have to search through all of it, you can literally go from smaller to larger key spaces and look for, you can organize it in certain fashions so that you are attacking either the simpler or the more likely first, instead of having to run through everything. So this is what Scoobs gave me as what this would look like if we stuck with the encoding the full name and spec of everything in the file name. That's 433 characters. It's completely unreadable, and most operating systems and file systems do not allow you to have more than 255 characters in a file name. So, sorry, but we can't keep that file naming convention, as descriptive as it is, although I don't believe most people would find that very descriptive. Depends, I guess, on who you ask.
Without file name completion, fat chance of anybody typing.
Do what?
Without file name completion, fat chance of anybody typing the file name in.
Well, yes, of course. And that wouldn't help them anyway. You wouldn't be able to create the file name. I don't think there's, not Windows, not Mac, not Linux, not any of the file systems will let you have a file name over 255 characters, I believe.
Yeah,
feel free to,
the standard quotas, like Unix file names are infinite in length, where infinity is set to 256 characters.
Right. Yes.
I'm pretty sure Windows allows you to have longer, but the programs within Windows won't let you.
I tried creating one that was exactly 257, and it said file name too long in Windows XP with an NTFS file system.
Yeah, okay. But the backend on NTFS, I think, allows longer.
Oh, maybe the file system allows it, but if Windows doesn't, it's okay. Let's see.
Again.
Yes.
So I find this sorting of the thing very interesting. Have you managed to validate with, for example, the data from whether it is actually true that from a given real-life set, the ones that you find first are the ones that you put on?
Well, actually, so that set, which will be our first hybrid 2 set, isn't generated yet. And this set, which is an example of possibilities of things that we can do in the future, is of course not generated yet. So, no, not yet.
It looks like an interesting thing to do, but also a non-trivial space to explore to actually verify that you have done the best possible thing given a specific data set.
Sure, right, and that's the we need quite a bit of data statistics to make sure that we're not making useless tables, and right, we're not trying to target one specific data set. Of course, sometimes, especially for corporate password statistics, everybody signed 6 NDAs before they even got to look at the password hashes, so it becomes a little bit harder. Our main focus is on NT-landman because the landman hash is at some point going to go away, and right now that gives us a very easy way to rather trivially break just about any Windows hash, and then once you've cracked the landman hash, it's simply a matter of case correction or Unicode correction to get to the NT hash. So you never have to attack the NT hash directly. Of course, that's going to change, and so thus our window for getting those statistics will continue to close, especially if somebody's got Vista 2008, which by default don't store the landman hash.
And
Although
is there any chance of this Windows moving to like something?
salted hashes, well, the landman hash, let's see, that's what they've had since, was it Windows 95 or 3.1?
No, 3.1.
3.1, and they added the NP hash somewhere.
In NT 3.1 or 3.5, I guess.
Right, and then it showed up in Windows 2000. None of the Win 9X series had it, and they've stored those two side by side since then. So, let's see, Windows 3.5.
Yeah, and with the Windows Vista and so 2003, you can still create landman hashes but the algorithm is disabled by default. So if you
Not on
create-
server 2003, on 2008. It's disabled. 2003 keeps landman enabled by default.
Oh, okay, sorry.
NT35 was around 94.
Right.
Yeah.
So we added the NT hash to the landman construction. So that's been what, 17 years? Can't do math anymore. At least not simple math with numbers. You know, I use letters. So it took that long for them to start phasing out the landman hash, and it's what, Perry, would you probably going to take 5 to 10 years to see the landman hash actually phased out?
Yeah.
And they don't even have assaulted anything on the horizon. Hang on one second. But so, yeah, assaulting would be a good start. Moving off MD4 would be a good start. But so, given how, when they finally added the NT hash and how long it's taken them to begin to phase out the landman hash, and they don't even have something to replace the NT hash, I think it's going to be quite a while before we see unsalted MD4 go away.
Let us just put it this way, Frank, if you should have any master students who need something more to do, I think James would be happy to introduce rainbow tables to them. So, but just go on with your presentation so we also make lunch.
Well, actually, I may be
Ahead of
made it a
schedule.
bit short.
Oh.
I was wondering, these sets that you have, they are for attacking the old landman hashes, or
We have sets for landman, MD5, NT landman, some SHA-1, MySQL SHA-1, which is just double SHA-1. That's actually our most incomplete hash that at some point we'll go back with GPUs and fill that out. Let's see. Oh, we do have some of the half landman challenge response. Am I missing any hashes?
when
No,
you
that-
asked the sizes for the key sets, that was for MD5, or is that?
For these?
Yeah, you had a list of the sizes of the subsets.
Oh.
For the,
Well, technically,
yeah.
this one?
Yeah.
Technically, it doesn't matter. Like, we haven't made this set,
Okay.
and Scoot specifically says, I'd really love this set, to see this set made so I don't have to make it myself. But it doesn't matter. Those key spaces that would apply to MD5, NT, LM, SHA-1, MySQL SHA-1, the key space for the passwords doesn't change with the hash algorithm, with strange exceptions like landman, because it splits it in half and it only has to link 7 and it's case insensitive. Yep, that was all that I came with. I probably ended up rushing through it because last time I did the opposite. But that's contact information for me. I did get cards made that on the back have my GPG key. I was very excited to already exchange keys with one person. Oh, now I'm afraid. All right. Show of hands for people that actually actively use PGP or GPG. Whoa, that's like double passwords 10. Anyway, so exchanging fingerprints on paper. Good. My business card, if you'd like to go that way. Our business card is kind of a funny term. They're cards that I made myself. I don't actually have business cards because I'm not a, I sit, you know, I'm a behind the scenes kind of person. They don't send me on advertising kind of things. So cards I made because after I got back from Norway the last time, people kept asking me to come talk at things, and everybody was always asking me if I had a card. So I was like, okay, I guess I should have some of those. More questions? No?
Yeah, before we give you the applause as well, I would also say that we are, the project is actually looking for storage space because the rainbow tables are now like 2-point-something terabytes.
We have 2.7 terabytes in RTI. That's going to drop in about half with RTI 2. The storage space actually doesn't become the problem. It's the hosting and bandwidth. Currently, our backend server is in Los Angeles, California, and has a full 100 megabit link, which when we're running full generation with GPUs, has a constant inbound from return results of about 23 megabits. That's the server handling the actual work. Once all the data is there and converted, it then has to make a very slow transit to Europe, and that has something to do with US peering providers. That it's very intriguing what they do on limiting data, but that then has to traverse to our primary mirror seed, which is actually in the Netherlands. And from there it goes to a server in Italy that's on the Italian Research Network at a university there. It's got full gigabit, but they also host things like Ubuntu and OpenOffice. And so after a new OpenOffice or Ubuntu release, their bandwidth is pretty much gone. We do have torrents for basically every set. We have several people in the community that have essentially found cheap hosting with a full 100 megabit connection, so most of them are seeded to a degree or another. So yes, if anybody has, let's see, because once we convert them and yeah, so if anybody has 2+ terabytes of disk space and 100 megabit plus of bandwidth with no usage caps, or has contacts at a university that may be interested, distribution is currently a large problem. And of course, anybody that likes programming, particularly C, Mark and I are kind of the majority of the programming team at this point. So it takes a bit of time for stuff to get.
Yeah.
And if you don't want to bother downloading them, you can pay and get a hard drive mailed to you with them preloaded.
That's true. That's actually our primary revenue stream, which is on maybe once a month, somebody will actually pay to have a hard drive shipped to them. And that's managed to keep us kind of balanced. I think we've had a month now and then that we actually had, hey, wow, we sold 2 drives this month, cool. All right, we can finally upgrade the server that is running with 8 gig of RAM and swapping 4 gig constantly. We can finally upgrade the RAM. So yeah.
And I will also talk to the university here in Bergen, and also probably to try to talk to NTNU at least, because the rainbow tables are definitely of research interest as well, so I will try to convince somebody into hosting them. And I mean, if you're interested in tables, I've got lots of them at home, and I will also join in onto the BitTorrent stream so that everybody can help out with sharing the rainbow table files.
And yeah, I was going to say, I should add, it's kind of funny when I give presentations and people say, well, you sell them on the site, you know, how can they be free and things like that. And so anybody that's local to anyone that has the tables, please share, copy drives, etc. You know, when I give talks locally, I'm perfectly happy, give me a hard drive and I will copy them. Here, you actually have all the ones that we've currently released.
pretty close.
I think.
Yeah.
So, but,
And copying 2.7 terabytes of data, that's like, you know,
yeah.
not a problem.
Yeah,
Yeah.
especially copying them to USB drives,
Yeah.
it takes about a day.
Yeah. Well, I think,
Literally.
yeah, we should give them a round of applause for James.